So we are going to understand the PpPpk, nothing but process performance indices. So what the customer felt quality will reflect in PpPpk. The organization perceived quality will reflect in CpCpk. Which is most important? The final quality is very important. What the customer is going to experience is very important. If your approach is that, then you must try to improve the PpPpk and not just CpCpk, right? And that's what we understood. So formula here. Formula is almost same. What is then different? The different is the kind of standard deviation you are using. Look at the PP formula. USL minus LSL divided by 6 sigma. Is it the same formula of CP? Same formula, but the difference is sigma is overall standard deviation. Earlier, the sigma used was within standard deviation. So what is within standard deviation? What is overall standard deviation? I am going to teach in this session, right? And now formula for overall standard deviation is square root of summation of x minus x bar the whole square divided by n minus 1. Now PpK. PpK formula is PP upper and PP lower minimum of. Almost same formula. But then what is the difference? Sigma is the overall. If you know what is overall standard deviation, use the overall standard deviation in the formula of the CPK or CpCpk. You will have PpPpk in your hand. Now, CpCpk is a reflection of your short-term capability. So PpPpk is the reflection of your long-term capability. Because in long-term, so many problems will happen, and then your capability will drop to a great extent, and that you will be able to capture by measuring PpPpk. Now, capability, you all know, is a function of variation and the position of the center. And then capability, we have two types. One is short-term capability, other one is long-term capability. What is short-term capability? CpCpk. Long-term capability, PpPpk. Short-term capability you can calculate using the formula. Same formula you can use it for calculating long-term capability also, PpPpk. But the kind of standard deviation you use, if the kind of standard deviation what you are going to use is overall, then you will be able to judge on the overall capability. If you use the standard deviation, these value, in short term, there are three types of standard deviation. Within standard deviation, between standard deviation, and combined standard deviation. If you understand within standard deviation, that is good enough. What is within standard deviation? The within capability. Yesterday, we measured the consistency within each appraiser. Am I correct? Consistency within each appraiser was called what? Repeatability.
Repeatability.
Consistency between the appraiser is called what? Reproducibility.
Reproducibility.
If you are consistent, if you also consistent within, if you are consistent between, and the result is what? Combined is what is called? The gauge R&R. Isn't it? Same logic. So there are three types of standard deviation here also exist. Within capability, between capability, combined capability. What is within capability? How do you collect the data? I hope one of you will agree with me. We generally collect the data every single shift. Am I correct? Every single shift you are producing. So every single data. The data collected within one shift, if we use it and calculate the standard deviation, that is called within standard deviation. How many of you understand the standard deviation now? Data is collected within one shift. Let us say you collected 5 samples. Now 5 data you have. With the 5 data, if you calculate standard deviation, that standard deviation is called within standard deviation. If within standard deviation is very small, what is your understanding? Why do you collect sample? One of you answer it. Why do you collect sample? Why can't you run the shift without collecting sample? Why are you collecting sample?
To check whether there is any variation.
Check whether my process is under control or not. To check.
You collect a sample to understand the quality of all the output that are going to shift. Am I correct? You collect sample to estimate on the quality of output that are going to come out on the shift. In a shift, how many units you will produce? Several thousand units. You can't check all each and every unit, isn't it? So you take 10 sample or 20 sample to judge on the 1000 unit. The variation in the sample, 10 sample, which is called within batch variation, will help you to judge on the quality of output produced only in that shift. You cannot use this very sample to judge your quality in the second shift or third shift, because sample is collected from where? From the first shift. That sample, that standard deviation can only speak about the quality of that particular shift. All of you are with me on this?
So, GK sir, you're saying that we assume we have 3 shifts in a day. So we will be taking the first shift sample only to see the standard deviation. That's what he said within, right?
Very good, correct. There are three shifts in any company in any single day. The sample collected from shift number 1 will help you to understand the quality of your shift 1 only.
Got it.
If you take the sample from shift number 2, that will reflect shift 2 quality only. If you collect sample from shift 3, that will reflect shift 3 quality only. But your boss wants the overall quality. Now, which sample will speak about the overall quality? All samples should be now combined. All the samples should now be combined. That is called overall standard deviation. Shift number 1, you have taken 10 samples. Shift number 2, you have taken another 10. Shift number 3, you have taken another 10. Each sample of 10 units will speak about the respective shift quality. But when I consider all the 30 samples together, now this will speak about the overall quality. All of you are with me on this? Right? So, use all the data if you are interested in overall quality, if you are interested in overall variation. Right? Use only the data collected in a particular shift to calculate within standard deviation. Then what is this between standard deviation? Your boss wants to know which shift quality is better and which shift quality is poor. Do you now understand the question raised by your boss?
Yep.
Boss is trying to find out which shift we are performing better. So he will compare standard deviation of sample 1, or otherwise, no, he will compare the data of sample 1, shift 1 with the data of shift 2, data of shift 3. How do you compare one set of data with other set of data? How do you compare me with you? You will calculate my average, and then you will calculate your average, and then you will find out the difference in the average. Am I correct? Yes or no? My average is compared against your average. This is called between variation. This is called between variation. Reproducibility. We called it as reproducibility yesterday. So shift 1 will have an average. Shift 2 will have another average. Shift 3 will have one more average. Now, how many average you have? 3 average. 3 data you have. Now, the difference that exists between the averages, you calculate a standard deviation using the 3 averages. That is called between standard deviation. Now, do you understand what is between standard deviation? How to calculate between standard deviation? Can one of you reframe the statement? How to calculate the between standard deviation?
The averages of
3 shift variation.
3 shift variations.
Average of the each shift should be calculated, and variation between the average is called between standard deviation. Right. Now you combine the within and between, that will be sigma combined. And right now I don't want you to worry about between standard deviation and combined standard deviation. Worry only about within standard deviation. Worry only about overall standard deviation. But this understanding will go a long way in making you a real statistician. Many of the problem in the world can be understood by knowing the intensity of the sigma. And 4 types of sigma exist. So 4 types of problems can dominate in any process. Right? And let us simplify the discussion: sigma within and sigma overall. When you use sigma within, your capability is within capability. Speak only about the particular shift, what you know from where you took the sample. That's called within capability. But when you use overall, now you can speak about overall capability. right? And let us move on. And when to use overall standard deviation? When your process is under complete statistical control. One of you told, you are plotting a control chart. If all your points are well inside the control limit, it is only at that time you must do the capability study. It is only at that time you must do the capability study. If any of the point is going outside, it is not healthier advice to go for the calculating the CpCpk or anything. In my opinion, only when your process is under statistical control, you must do the capability study. Right. So suppose you, for certain reason, whether your process is under statistical control or not, your boss wants to know the capability. Then under such situation, if your process is under statistical control, yes, you pass on this value to your boss CpCpk. But if your process is not under statistical control, but still your boss wants to know the capability, then you must bring only PpPpk to his notice, because only PpPpk will reflect the real quality of the performance, right? All right. Now let us take an example. Imagine you are producing some coating process. You are doing a coating, and this is, let us say, this is something like coating thickness or something, right? And it is measured in microns. So 50 micron is the expectation. Let's say 50 micron is the expectation. And customer has given a specification 50 plus or minus 3. Now what is USL? 53. What is LSL? 47. And now you use the raw material. The raw material comes in rolls. First roll is processed. Second roll is processed. How many rolls are used? 25 rolls. 25 roll. Now there are a lot of variation that can play in any process. Hope all of you agree with me. Now I am bringing one more source of variation, which is called roll-to-roll variation. Am I correct or not? Roll number 1, when you use a particular quality, you will achieve. The roll number 2, you use another quality, will achieve, right? So the roll-to-roll variation, all the variation will come and play. That is why we must measure PpPpk, because PpPpk captures all sources of variation, but CpCpk doesn't capture all sources of variation. For example, shift number 1, the roll number 1 will be utilized. Do you think your shift variation will measure the roll-to-roll variation? Throughout the shift number 1, which roll is used? Roll number 1. Then next shift, the roll will be changed. Now within every shift, the roll is not changing. Do you get my point? Within every shift, roll is not changing. But when you consider overall, roll is changing continuously. So which is going to give a real picture of the capability? Considering all the variation, isn't it? That is why PpPpk is a best measure. Now we will do all the calculation for this problem. Now every roll, I have taken a sample of 3 components and the data is recorded. So every time you take a sample, that is called a subgroup. So 25 rolls are used. 25 times I have taken a sample. So 25 subgroups I have. Each subgroup has 3 data points. What is the subgroup size? 3.
3.
Right? 25 subgroups and subgroup size is 3. With that, I am going to calculate CpCpk, everything. Number of subgroups, nothing but number of roles, 25. Subgroup size, the number of data in each subgroup, which is 3. Now, total number of data. What will be the total number of data? 75. Isn't it? 75. Now you need to calculate sigma within. The formula for sigma within is R bar by T2. Why? I need standard deviation, but I use the range. I use the range and then convert the range into standard deviation, simply because my subgroup size is less than 8. Whenever my subgroup size is less than 8, range is the best measure of variation. See, variation can be measured in terms of range, in terms of standard deviation, in terms of variance. Isn't it? When to use range? When the number of data is less than 8. Since your subgroup size is 3, calculate the range. So how many range will be there? 25 range will come, isn't it? So calculate all the 25 range and then average the 25 ranges. What is average of the ranges? Add all the ranges, R1 plus R2 up to R25 divided by 25. That will give you the average of the range. This is R bar, not R. This is R bar, right? R bar is obtained. Now D2 is a statistical constant. While plotting the control chart, and whenever you want to convert the range into standard deviation, statistician has developed a table. The value of D2 depends on the subgroup size. What is your subgroup size? 3. For a 3, D2 is found to be 1.693. This table is available in Google, and I have also shared it in the middle. Also, you can see. So 1.63 is used. The average of the range is used. R bar by D2 will get me sigma within. How much is sigma within? 0.4139. All of you understand how sigma within is calculated?
Yes.
Sigma within, substitute in the form, the resulting capability is CpCpK. That is nothing but CpCpK. That CpCpK should be not technically or theoretically called as within capability. What is that? Within capability. Now, another standard deviation we need to calculate. What is that? Overall standard deviation. How to calculate overall standard deviation? How many data totally you have? 75. Is it possible you can calculate standard deviation using all the 75 data? Possible or not possible?
Not possible.
Satish, why you are saying not possible? I give you 75 data. The formula, substitute and get the standard deviation. You have totally how many data? 75. Combine all the data, 75. And go to Excel, RK template, go to Minitab, or use your own intelligence. You get the sigma. That sigma is nothing but 0.8384. This S is not required, but it's an excess information, right? So 0.8384. Do you all understand how this sigma is? Look at the difference in the sigma. Earlier sigma was 0.4. Now sigma is 0.8. Why there is a difference? Earlier the roll-to-roll variation was not accounted properly. Am I correct?
Yes.
When I consider all the data, roll-to-roll variation also accounted. So when you use this standard deviation, your capability is going to be different. When you use this standard deviation, your capability is going to be completely different. If you use within standard deviation, that is nothing but CpCpK. If you use this standard deviation, this is nothing but PpPp. Which will give the real picture? Which are you worried about? Are you worried about overall capability? Or are you worried about the shift capability? I need shift capability also. I need plant capability also. I need overall capability also. So your eye should be on sigma overall. Your eye should be on PpPpk, right? So use the sigma within. Look at your CpCpK value. They're looking very great. 2.46 and 2.37. No rejections. But for the same situation, same company, same data, look at your PP value. That means if you are too happy about your performance and run the company for continuously, within another several weeks, there will be a lot of rejection. These are all happening or not? These are all happening. You think your CP is great, but still there are a lot of rejections, a lot of problem, a lot of argument, because you have not kept your eye on the PP. Keep your eye on the PP. PP can also be closer to CP. If that situation happens, that is the best situation. That is the capable factor. Is that clear to all of you?
Yes, sir.
Right. This is the table I was talking about. For a subgroup size of 2 up to 25, the values are given. Which value is used to be required for us? D2. For a value of 3, what is the D2 value? 1.693. So this is the picture of the thing. We can feed the same data in Minitab, and Minitab can throw away all this report in no time. Right? See here, CP is 2.46, CPK is 2.37. But for the same situation, what is the PP? 1.19 and 1.15. We did it manually. Minitab confirms it. That means our understanding is on par, isn't it? This is what is required before you start using any software. Even before you start using any template, you must understand the subject. Absolutely, there is no need for us to teach all these things. We can simply give you the template. We can train you on Minitab. We can still call it as a black belt training program. That's how trainings are happening. But any template before using, you should know, right? The terminologies, the jargons connected to it. And then you can better understand. Now, this green color one is nothing but the CpCpK capability. Sounds very good. Your curve is narrower, looking like a giraffe. But this red color curve represents your PpPpK. Looks like an elephant, isn't it? What is required? We need process more capable, the giraffe one, right? All right, so this is the actual capability, red one. And this is the potential capability. Now it is in your hand, whether you want to be in dreams or you want to come to the reality. Always, we dream a lot, and the dream is reflecting in your CPCPK. But what is the reality that reflects in your PPPK? Yes. And now again, see here, another capability is also that if you want to understand, you can understand. B means between within capability. How to get between within capability? By combining within standard deviation and between standard deviation. Purposely, I have not taught you between standard deviation to confuse you much. Isn't it? So calculate the within standard deviation, get your CPCPK. Calculate the overall standard deviation, get your PpPpk. Maybe at the next stage, you come to me, we'll talk about the remaining two also. What are the remaining two? Between standard deviation,
Combined.
is within between standard deviation. Always we can confuse with many metrics, but let us keep things simple and then work it out. See here, based on your CPCPK value, the ppms are calculated. The ppm is parts per million below your LSL. Here ppm above USL and ppm total. Observed is 0, but still, according to the overall thing, you still rejection. But if you use this, between within capability, that will take you close to PpPpk. That's somewhere in between value, right? Similarly, in the previous also it should be available. Oh, it's available. See here, DPMO is calculated and everything, has come. And see here, Z bench. The Z bench is nothing but G score, the sigma level. We will anyway give you clarity on all those things. We are going to have some, the next session is about statistics. I'm going to talk to you about statistics. So overall standard deviation, and then we used within standard deviation. There is one more thing called between standard deviation. You combine the within between, you get this. It all depends on what you really want to understand. As a black belt, please have a thorough understanding on within standard deviation and then overall standard deviation. Within will give you CPCPK, overall will give you PpPpk. All right. Whenever your process is statistically out of control or whenever your concern is about the overall performance, you must use PpPpk only. Right? So now look at the process. Is this process under statistical control or out of control? So many points are falling outside. Under such situation, it is not advisable to do the capability study at all. You are not eligible to measure your capability. Why? There are serious failures happening. Why do you want to understand your capability? First, to correct that. No, projects are required. And then to rectify that. Do that job. But for some reason, if you want to calculate PpPpk. That will give the real picture. Right? Hope it was helpful to all of you. Right? You gained the clarity of, when to use CPCPK and when to use PpPpk. Any questions?